again from ST. We are very excited and to partner with Autocore. We showcase the use case audio over Ethernet that in automotive it's a major one in the embedded world. And here, Yang will explain. Thank you.
Thank you, Michael. I realize I'm the last one, so standing between you and drinks, so I'll keep this short. Autocore is a startup founded back in 2018. We're 8 years old now, not exactly a small startup. We're very excited and thankful for the sponsorship from ST. Autocore has developed a full-stack SDV solution. We have been supplying to some of the most highest volume supply, including Volkswagen, BYD, etc. From 2022 SOP. So today we're sharing the latest collaboration with STMicro based on the Stellar, very powerful, capable Stellar MCU series of the zonal computing solution to support the whole vehicle high-fidelity audio. So before that, I want to give you a glimpse in terms of what Autocore's main product portfolio looks like. So as we all know, the EE architecture of the vehicle has evolved from discrete to domain-centric. Right now, mostly move on to the next generation of a centralized zonal computing architecture. So what Autocore's main product focus on delivering the full stack of CCU HPC stack as well as the full stack of zonal computing solution. And this is where we interact with MCU, Stellar MCU from STMicro. So the solution we're showing you today is a distributed amplifier over automotive Ethernet. So on the left is what we typically see, right, in the vehicle. We are seeing a bunch of analog routing with a complex, a bunch of A to B with a complex analog routing, which is very heavy, costly. And it's subject to a lot of interference in the EMC issue. What actually we're seeing here is in the latest EE architecture, we already have very much bandwidth and powerful the main bus, which is the Ethernet, in the vehicle. Why don't we take a full advantage of it? That's what this solution is showing you, how we can deliver in higher fidelity audio solution based on the Ethernet main bus. This is what the eventual solution looks like. We will have a central computing unit where it's handling the Ethernet switch, multiple zonal controller, what you see in the vehicle. Delivering on top of Stellar MCUs, we are able to achieve very high performance, which I will show you quantitative measurement in the next slides. So ST obviously based on providing the Stellar MCUs and also lower level drivers for the audio, based on a very powerful chip. And Autocore will supply the full TSN stack and a software architecture integrating across the whole vehicle. So this is something which we are already designing multiple OEMs. So this is kind of a data point you will be interested in. I think the $30 has been very conservative because in some of the vehicles designing, we're looking at it between $70 to $100. BOM cost reduction directly with, without any other subcomponents included. So this is based on a 32 speaker system. So it's a very complex, not one of those very simple ones. So we are looking at a 40% reduction based on the harness weight alone. Okay, we are able to achieve a multi-speaker phase deviation less than 10 microseconds. So what that means is that you will able to achieve the highest level of audio fidelity what you currently seeing in the car, in the most complex speaker organization. The clock synchronization accuracy is less than 1 microsecond. Typically, we're measuring that in terms of 200 nanoseconds. Okay. So so that's something which, as we discussed, a lot of people think is quite challenging to do. In non-deterministic bus, such like Ethernet, we're showing you today, this is not only impossible, this is production ready today. That is all. So thank you very much. If you are interested, please contact either ST or Autocore myself. Thank you very much.